Now let us start the practice set 5.3. Here first example is given. Angle made by the line with the positive direction of the x-axis are given. Find the slope of this line. तर आपल्याला इथं काही लाईन्सचे स्लोप अँगल दिलेले आहेत आपल्याला. द angle made by that line with the positive direction of x-axis is given and we have to find the slope of the line. So first example is from 1. First example we have given 45 degree. 45 degree. तर आपल्याला माहिती आहे अँगल ज्या मेजरचा असतो त्याचा tan रेशो काय असतो आपला स्लोप असतो. सो हियर वी विल राईट slope of line is the tan ratio of the angle made by that line with positive direction of x-axis. Positive direction of x-axis. So here we can write slope will be equal to tan 45 and we know the value of tan 45 is 1. So slope of that line is 1. So slope is equal to 1. Then we have number 2. We have 60 degree. Then we have given number 2 60. So here we can write slope equal to tan theta. Here theta is given, that is 60 degree, and this is the tan of 60. Tan 60 आणि tan 60 ची व्हॅल्यू आपल्याला माहिती आहे किती आहे √3. So this is √3. Third example is we have given the angle is 90 degree. So here theta is given 90 degree and our slope here will be equal to tan of 90 degree, and this is tan 90 is not defined. This is not defined. Here we have to find the slope of the line passing through the given point. आपल्याला काही पॉईंट दिलेले आहेत आणि आपल्याला त्यांचे स्लोप काढायचे आहेत. फर्स्ट एक्झाम्पल इज गिवन, दॅट इज पॉईंट ए, दॅट इज 2 3 and b is 4 7. So let we will consider this x1 y1, this is x2 y2. Let a is a point 2 3 we will consider as x1 and this is our y1. Then point b 4 7 has x2 and y2. स्लोप ऑफ लाईन ए बी. आता ए बी पॉईंट आहे तर आपण स्लोप ऑफ लाईन ए बी लिहू. स्लोप ऑफ लाईन ए बी will be the difference between y coordinate upon difference between x coordinate. So this will be 7 minus 3 upon 4 minus 2. So this will be equal to 7 minus 3 is a 4 and 4 minus 2 is a 2 and slope will be equal to 2. So slope of line AB is 2. Number 2. Here we have point P minus 3 1 and other point is Q 5 minus 2. Let us consider this x1 y1 and x2 y2. Let point P minus 3 1 is x1 y1 and point Q 5 minus 2 is x2 y2. Slope of PQ. Slope of line PQ will be equal to 1 minus minus 2, 1 minus minus 2, minus 3, minus 5, which will be equal to 1 minus minus plus 2 upon minus 5 plus 3 will be equal to minus 2, and so this will be 3 minus 3 upon 2. Then next point we have given C. C is a point having 5 minus 2 and D 7 3. Now consider this point as x1 y1 and x2 y2. So this is point C. 5 minus 2 will consider as x1 y1, and point D 7 3, which will be x2 comma y2. So slope of line CD, slope of line CD will be equal to y2 minus y1, 3 minus minus 2, and upon 7 minus 5, which will be equal to 3 minus minus plus 2 upon 7 minus 5 is again 2. This will be 5 by 2. Fourth example, we have given point L, that is minus 2, minus 3, and M minus 6, minus 8. Let L is a point minus 2, minus 3. This is our x1, y1. M is point minus 6, minus 8. This is x2, y2. Now slope of LM, slope of line LM is given by, that is y2 minus y1 or y1 minus y2. We will take y1 minus y2. This will be minus 3 minus minus 8 upon minus 2 minus minus 6. This will be equal to minus 3 plus 8 and minus 2 plus 6. So 8 minus 3 is a 5 and 6 minus 2 is a 4. So slope is 5 by 4. Is 1 plus 2 upon minus 8, and this is equal to 3 upon minus 8. Example number 5. Here is point E minus 4 minus 2 and point F 6 and 3. Now consider minus 4 minus 2 is x1 y1, F 6 3. This is x2 y2. Now slope of line EF, minus 2 minus 3 upon minus 4 minus 6, which will be equal to minus 3 plus 2 is 5 upon minus 6 plus 4 is 10. So minus minus will be plus 5 upon 10, and this will be 1 is to 2. This is 1 upon 2. The slope is 1 by 2. Next example, example number 6 is 0 minus 3. Point is 0 minus 3 and S04. So P is a point 0 minus 3 and S is a point 0 4. So this is our x1 y1, x2 y2. So slope of line ST or TS, slope of line ST will be minus 3 minus 4 upon 0 minus 0, which will be minus 7 upon 0, and minus 7 upon 0 is not defined, which will be equal to not defined or not determined. Here we have to determine whether the following points are collinear. दिलेले पॉईंट कोलिनियर आहेत किंवा नाही हे आपल्याला शोधायचं आहे. त्यासाठी आपण आधी एक कन्सेप्ट लक्षात घेऊ. जर दिलेले 3 पॉईंट कोलिनियर पॉईंट असतील तर काय होईल. समजा आपल्याला एक लाईन दिलेली आहे. या लाईनवर आपल्याला 3 पॉईंट दिलेले आहेत ए बी सी आणि हे 3 कोलिनियर पॉईंट आहेत. तर पाहिलं आपण तर इथं ए बी लाईन, बी सी लाईन, ए सी लाईन एकच लाईन आहे आणि तुम्ही कुठेही स्लोप घेतला, या लाईनवर कुठलेही पॉईंट घेतले तुम्ही तर त्या लाईनचा स्लोप कसा असणार आहे, सारखाच असणार आहे. जर आपल्याला दिलेले 3 पॉईंट असे असतील समजा, तर ए बीचा स्लोप आणि बी सीचा स्लोप हा सारखा जर येत असेल आणि पॉईंट बी हा जर कॉमन पॉईंट असेल तर काय म्हणू शकतो आपण, ए बी सी हे तिन्ही पॉईंट कसे येतं, कोलिनियर पॉईंट आहेत. आपल्याला हाच कन्सेप्ट इथं वापरायचा आहे. 3 पॉईंटपासून आपल्याला 3 वेगवेगळे काय बनू शकतात, ए बी सी कोलिनियर असतील तर आपल्याला ए बीचा स्लोप आणि बी सीचा स्लोप सारखा असेल आणि बी हा कॉमन पॉईंट असेल. त्यावेळेस आपण काय लिहू शकतो, तिन्ही पॉईंट हे कोलिनियर पॉईंट आहेत असं आपण म्हणू शकतो. तर इथं आपण आता ए बीचा स्लोप काढू, त्यानंतर बी सीचा स्लोप काढू आणि नंतर एक कुठला तरी पॉईंट जर कॉमन पॉईंट आहे, बी हा कॉमन पॉईंट दोन्हीमध्ये जर येत असेल तर आपण असं म्हणू शकतो की ते तिन्ही पॉईंट कसे आहेत, कोलिनियर पॉईंट आहेत. थोडक्यात आपल्याला 2 जे सेगमेंट येतील किंवा 2 लाईन येतील त्यामधल्या त्याचे आपल्याला स्लोप कसे दाखवायचे आहेत, सारखे दाखवायचे आहेत. तर इथं आपण स्लोप ऑफ ए बी काढू, त्यानंतर स्लोप ऑफ बी सी. हिअर स्लोप ऑफ ए बी, ए बीचा स्लोप कसा लिहू शकतो आपण, वाय कॉर्डिनेटचा डिफरन्स -1 -1 अपॉन -1 -0 आणि -1 इज -2 अपॉन -1 -0 इज -1 अँड दिस इज 2 अपॉन 1 विच इज इक्वल टू 2. तर आपल्याला ए बीचा स्लोप 2 आलेला आहे. त्यानंतर बी सीचा स्लोप काढू आपण, स्लोप ऑफ बी सी 1 -3 0 -1, so this will be -2 upon -1, this will be equal to 2 upon 1 which is equal to 2. तर दोन्ही लाईनचा स्लोप कसा इथं सारखा आलेला आहे. स्लोप ऑफ ए बी इज इक्वल टू स्लोप ऑफ बी सी अँड बी इज द कॉमन पॉईंट इन बोथ द लाईन. Here we can write slope of AB, slope of line AB is equal to the slope of line BC. Point B is common point. So here we can write points A, B, C are collinear point. Here we have given point D, A and F. 3 points are given. We will first find the slope of line D, then slope of line EF. So here we can write slope of line D which will be equal to -3 -0 upon -2 -1. So this will be -3 upon -3 which will be equal to +1. So slope of line D is 1. Then find the slope of line EF. slope of line EF will be equal to 0 minus 1 and 1 minus 2, which will be minus 1 upon minus 1 and which is 1. Again here slope of both lines are equal. So we can write slope of line DE is equal to slope of line EF, and point is common point, is the common point, and so we can write DEF are collinear point. So points D, E and F are collinear points. Next we have given example number 3, L, M and N. So here we will first find the slope of LM, then slope of MN. Slope of line LM, which will be equal to 5 minus 3 and 2 minus 3. This is 5 minus 3 is 2 and 2 minus 3 is minus 1. This will be minus 2. Again find the slope of MN. Which will be equal to 3 minus 1 and 3 minus 5. 3 minus 1 is 2 and minus 5 plus 3 is minus 2. So this will be minus 1. So here slope of LM and slope of MN are different. So here we will write slope of line LM is not equal to slope of line MN, and we can clearly say that the point L, M and N are not collinear point. Points L, M and N are not collinear points. Here we have given point P, Q and R. Find the slope of PQ. Slope of line PQ, which will be equal to minus 5 minus minus 3 upon 2 minus 1. So this will be equal to minus 5 plus 3 upon 2 minus 1 is 1. So this will be minus 5 plus 3 is minus 2, and slope of line PQ is minus 2. Then slope of line QR, this will be minus 3 minus 3 minus 3 upon 1 minus minus 2. So this will be minus 6 divided by 1 plus 2. This is minus 6 by 3, and this is 3 1s are 3, 3 2s are 6. So this is also minus 2. So here clearly we can say that the slope of line PQ and slope of line QR are equal. So slope of line PQ is equal to slope of line QR. Point Q is common point. Also point Q is common point. So we can say that points P, Q, R are collinear point. Next we have point R 1 minus 4, S minus 2 2 and T minus 3 4. Now find the slope of RS. Slope of line RS, which will be minus 4 minus 2, 1 minus minus 2. This will be minus 6, 1 plus 2, minus 6 upon 3. This will be minus 2. Then find the slope of ST. Which will be equal to minus 2 minus 4 and minus 2 minus minus 3, which will be, this will be minus 4 plus 2 is minus 2 upon minus 2 plus 3. This will be minus 2 upon 1. This is minus 2. So slope of RS is equal to slope of ST. Slope of line RS is equal to slope of line ST, and point S is common point. Point S is common point. So point R, S, T are collinear point. So points R, S, T are collinear points. Next example, we have point A minus 4 4, K minus 2 5 by 2 and N is 4 minus 2. Now find the slope of AK. Slope of line AK, which will be equal to 4 minus 5 by 2 upon minus 4 minus 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 4 minus minus 2, which will be equal to, so this we will solve this. This will be equal to 2 into 4 is 8 minus 5 into 1 is 5 divided by 2 into 1 is 2 upon minus 4 plus 2. So this will be 8 minus 5. 8 minus 5 will be equal to 3 upon 2 upon minus 4 plus 2 is minus 2. Now to cancel this 2, multiply numerator and denominator by 2. So this will be equal to 3 by 2 into 2 upon minus 2 into 2. So this 2 get cancelled and we get 3 upon minus 4, that is minus 3 by 4. Slope of line AK is minus 3 by 4. Now find the slope of KN. Slope of line KN will be equal to 5 by 2 minus minus 2 upon minus 2 minus 4. So this can be written as 5 upon 2 minus minus plus 2 upon 1 upon minus 6. Now 5 into 1 is 5 plus 2 into 2 is 4 upon 2 divided by minus 6. So this will be 9 by 2 upon minus 6. Now multiply numerator and denominator by 2. Here we will get, so this 2 get cancelled. This is 9 minus 12, which will be equal to 3 into 3 9, 3 into 4 is 12. So this is minus 3 upon 4. So slope of both the lines are equal. Slope of line AK equal to slope of line KN and point K is common. Point K is common point. Slope points A, K and N are collinear point.